All right, so what I said was that we're not really going to graph. We'll put all those pieces together by the end of the chapter, but we are going to talk about end behavior, how to sketch it, and how to note it. What's the proper notation? So if I have an odd function and a positive leading coefficient, we're very familiar with x. What does y equals x look like? That's a line. Or even y equals 3x plus 7. That's a positive leading coefficient. What is that? That looks like this. So what's happening at the ends? We're talking about end behavior. Well, the value of the function goes to negative infinity as x goes to negative infinity. I don't really like the way your book writes this. I wish they'd say what happens as we go, as x goes to a negative infinity, what happens to the function. But they do it this way, so I'll stick with it. So if I'm looking at the end of the function, this is going to keep going to negative infinity as x goes to negative infinity. So that's what I'm saying. The value of the function goes to negative infinity as x goes to negative infinity. So as I'm tracing this function along towards negative infinity, I'm going to keep going down towards negative infinity. But what happens as x goes to positive infinity? Well, the value of the function goes to positive infinity as x goes to positive infinity. So this could be, if it's an odd function, it could be an x to the first, an x cubed, an x to the fifth, etc. So who knows what goes on in between here? There could be a bunch of curves depending on what degree the polynomial is. But the end behavior will always behave the same way. If you have an odd function with a positive leading coefficient, it's going to go down to the left and up to the right. Down to the left and up to the right. And how do we say that? We say the value of the function goes to negative infinity as x goes to negative infinity. Down to the left, up to the right. The value of the function goes to positive infinity as x goes to positive infinity. So I know what the ends of the function look like. Now what about if I'm talking about an odd function with a negative leading coefficient? Again, if I asked you guys to say, well, what does negative 3x plus 7 looks like? Well, that's going to go down to the right and up to the left. So down to the right and up to the left. And again, how many squiggles I have in here depends on the degree of the function. But overall, the ends behave the same way. The value of the function goes to positive infinity as x goes to negative infinity. So as I head out on the x-axis towards negative infinity, my function's going to go to positive infinity. As I head out to positive infinity on the x-axis, the value of my function's going to negative infinity. That's why I think they should write it the other way around, but I didn't write the textbook, so I'm trying not to confuse you, but I'm probably confusing you. So I have this thing, I'm upside down. That's kind of funny. Anyway, well, I'll just leave it like this, but I tend to take my arms and say, look, I'm either going like this or like this. I'll show you when you get back. All right, what about if we have even functions? So again, you guys are familiar with an even function. A parabola is an even function, an x squared or an x to the fourth or an x to the sixth. And we all know what parabolas look like if their leading coefficient is positive. And again, depending on whether it's a 4 or 6, this thing could do like a couple of squiggles or more than that or less than that. And so what's happening? The value of the function is going to positive infinity as x goes to negative infinity. The value of the function is going to positive infinity as x goes to negative infinity. Here again, the value of the function is going to positive infinity as x goes to positive infinity. So whether I go way to the left or way to the right, I'm always going, the value of the function is always going up, the y value. What happens if I have a negative number out front? What if it's a negative 6x to the fourth or a negative 5x to the sixth? Don't get confused. This is an even function because the degree is even. The leading coefficient doesn't matter whether it's odd or even. It does matter whether it's positive or negative. So a negative leading coefficient, an even function. A negative leading coefficient, an even function. So it either goes, they either both go up, if it's positive leading coefficient, or they both go down. So how do I say that? I say the function goes to negative infinity as x goes to negative infinity. The function goes to negative infinity as x goes to positive infinity. So either way, if I'm going out to the left or out to the right, the value of my function is going to continue to go down to negative infinity. And again, I could have a truckload of squiggles in there if that was an x to the 8th or something like that. So if you look on page 339 in your text, there's a quick picture of that. You guys had access to your text, so it's explained like that. So I was trying to be consistent with your text, even though I sort of disagree with how they write it. I would just say the x part first and the f of x part second. That's all. So what do we have to do with that, Viv? Well, you have to do a couple things. In practice A, you have to do some matching, and in practice B, you have to do some describing and sketching. So in practice A, here's my two functions, which goes with which. Well, I see this is an odd, it's an odd degree with a negative leading coefficient. So that's got to be A. This is an even, and remember, an even either has to both go up or both go down. So this is a positive leading coefficient, so they both go up. So that's got to be this one. This is a negative odd, so it goes down. Just like a negative line would look like that. Just like a positive parabola would look like that. Just worry about what's going on at the ends. So here I go. I have a negative leading coefficient, and I have an even function. So if it's even, it's either got to both go up or both go down. In this case, since my leading coefficient is negative, it looks like that. There's my sketch of the end behavior. So what's happening here? The value of my function is going to negative infinity. It's going down. As x goes to negative infinity. As I go to the left, my function goes down. As I go to the right, my function goes down. So my function's going to negative infinity as I go all the way to the right. That would be positive infinity on the x-axis. Here's a positive leading coefficient. It's an odd function because that's an x to the third. So just like a positive line would go like this, I'm going to go down to the left. I should have put my axis up there, and up to the right. So the value of my function is going to negative infinity as x goes to negative infinity, right? The value of my function is going to negative infinity as x is going to negative. If I'm tracing the function out to the left, it's going to go down. If I'm tracing the function out to the right, it's going to go up. So the value of my function will go to positive infinity as x goes to positive infinity. The instructions on the practice might say graph it, but I'm going to tell you to just describe and sketch the end behavior. So there's the sketch of the end behavior. There's the description of the end behavior. And that's it for 5.2. Halfway there.